The following presentation was recorded at the 2012 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2012 for helping make these videos possible.
Mether, and he's going to be talking about MariaDB, replacement for MySQL.
Yes, with a question mark. Yeah, I'm going to talk about MariaDB. And actually, before I start talking about MariaDB, so my name is Max. I'm from Finland originally. I now live in Georgia, so not very far from here. And I work for a company called SkySQL, and I used to work for a company called MySQL since a long time. Before I start, who here has used MariaDB? Okay, like 3 people. Okay, not a lot. Who has used MySQL? Okay, who has not used MySQL? 1 guy. Okay, good. So I don't have to explain what MySQL is then. So basically in this talk I'm going to talk about a bit generically stuff about MariaDB, how it came to be and stuff. And then I'm going to focus on technical features that are present in MariaDB and not in MySQL, well, yet at least in MySQL. So first of all, a really quick introduction. What is MariaDB? It's a branch of MySQL. It's backward compatible. It's a drop-in replacement. So if you're running MySQL, you can stop your server, put MariaDB on the same data, and it will work. So it's a drop-in replacement of MySQL. Does it use the same configuration file? Yes. I mean, if you go from one version to the other, you will have the same potential version incompatibilities that you would have with MySQL. But other than that, yes, it works. MariaDB is truly open source, so the source code is available on Launchpad. Everything that's ever in MariaDB is open source. There's no closed source modules like in MySQL. And the bugs database is open as well. So all bugs in MariaDB are accessible to the public in a public database. All right, that's the background. That's what MariaDB is. Right? So now a bit of history. So MySQL was created, well, the first version of what would eventually become MySQL was created a long, long time ago by one guy called Monty Vedenius, who was then living in Sweden, but he's Finnish, if anyone cares. And this was back in '83, so a long time ago. And this thing, it was called Unireg at the time, was very far from MySQL, but it was a database. He created it for his own needs. He was working as a software consultant, doing, well, software development for clients. So he created a database that he would then install at clients' places and stuff like that. And this first version was created on a very specific platform. Platform is not open source, it was not in C or anything like that. So it was very far from MySQL. And then later on, the platform where this MySQL prequel was living was actually ended. It was end of life. So they were saying, all right, the platform is going to go away. We don't have enough customers. So he had to do something with his Unireg, as it was called. So he decided to recode the whole thing into C, and he also decided to release it as open source. And well, it was a hard decision actually, because he was selling his thing for customers, and he was scared of doing this open source. He was like, well, if I open source this, why would anyone ever pay? But his friend David Axmark convinced him that it's the right thing to do. And partly because they had been using open source tools in their development, they said, okay, well, maybe it's time we give something back to the community. Let's release this open source and see what happens. And it happened, well, it turned out to be quite a good thing. So MySQL, the product was released in '95. At the same time, the company, MySQL AB, was created. There were 3 in the beginning. Well, a few years later, the company was acquired for $1 billion by Sun. So it was a good idea. I mean, MySQL was in the right place at the right time, right? It was released in '95, basically when internet was rising, and the LAMP stack became a thing, and everyone had a LAMP stack, and it included MySQL and so forth. Right, so we fast forward a bit. MySQL AB is acquired by Sun. The company was around 500 people at the time MySQL was acquired. So it was already growing into a larger organization, but still 500 is nothing compared to Sun, who was whatever Sun was at the time, 50,000 or something. So quite a few people actually left when MySQL was acquired by Sun, including the original creator, Monty Videnius. So he left Sun. He took many of the core developers with him, or well, they followed. I guess he didn't take them, he didn't force them, but they volunteered and joined him. They created a company called Monty Program, and the original plan was to do development for MySQL. So they wanted to do development for MySQL, but they didn't want to work for a big company. And that was the original plan. Then Oracle acquired Sun in April 2009. And well, they decided to change their plans. Instead of just doing development for MySQL, they decided to create a branch or a fork of MySQL. And then MariaDB 5.1 was released in February 2010, so the first version of MariaDB. So that's kind of the history behind MariaDB. Yeah, well, a very brief version of the history. So who's behind MariaDB? Well, Monty Program, so the company I talked about, the core developers of MySQL, former core developers of MySQL. And they have the same kind of development model as MySQL used to have. People work from home, they communicate through IRC and Skype and so forth. However, they're by far not the only contributors to MariaDB. MariaDB is a true kind of open source project in the sense that a lot of the development is also from people outside the Monty Program company. Many of the features that I will talk about later were actually originally developed by someone else, and then Monty Program just ported it to MariaDB. Some other features were actually created by others outside the company directly into MariaDB. So they have so it's on Launchpad, and they have captains who basically are allowed to commit code to the MariaDB project. And well, this statistics was like 6 months ago. So 64% of the captains were from Monty Program, and 36 were community people from outside the company. So it's a true, even though it's largely dominated by Monty Program, it's still a true open source project. So there are people outside the company who commit code and who are allowed to accept commits to the tree. Right. So that's one of the goals of MariaDB, to be community developed, stable, and free. So free in the sense of open source, not free beer. But it's also free, of course. You don't have to pay for it. All right. That's kind of the background. Now I'm going to start talking about features. So, well, if you have any questions about these features, feel free to interrupt me, but 1 hour is kind of short. So I have here a list of features, which is not all the features that differ between MariaDB and MySQL. It's kind of the major features, but there are others as well. And also note that I have the features in the order they were introduced into MariaDB. So the GA version of MariaDB is MariaDB 5.5, which is based on MySQL 5.5. But here these features will be in kind of chronological order when they were introduced. So I'm going to start with features introduced in MariaDB 5.1. And these features are still present in 5.5, except if there's something here like this star here. PBXT is no longer there by default, for example. So the first release of MariaDB is MariaDB 5.1. So it was based on MySQL 5.1. It had a few new features, storage engines that weren't in MySQL, notably XtraDB, which, who knows what XtraDB is? No one. Who knows what InnoDB is? Okay, InnoDB, yeah. So XtraDB is actually an open source version of it. Well, InnoDB is also open source, but it's just a a fork or a branch of InnoDB. So it's InnoDB with some added features. Back in MySQL 5.0, Google released patches to InnoDB that made InnoDB more usable for multi-core environments. And because of various reasons, MySQL was unable to include these patches into the InnoDB tree. So basically MySQL, if you download MySQL 5.0 and 5.1, you didn't have these improvements. And that's how ExtraDB was created originally. So it was basically an open source version of InnoDB with the Google patches that made InnoDB more usable for multi-core environments. And now ExtraDB has evolved. It's maintained now by Percona, and they've added some instrumentation and other features to InnoDB. So ExtraDB is very close to InnoDB, but with some small differences. When ExtraDB was first introduced, there was a big gap between InnoDB and ExtraDB. Now there's a much smaller gap, but there's still a bit of a gap between the two.
Is it a transparent replacement for InnoDB for existing applications?
Yes, it's transparent. In MariaDB 5.5, the default is ExtraDB. So it looks like you're using InnoDB, but you're actually using ExtraDB. But you can actually switch and use InnoDB if you prefer using the same InnoDB as in MySQL 5.5. But by default, it will be ExtraDB, but you won't notice the difference because it's 99% of the code is the same. It's just a few add-ons. They added a few more storage engines. One is Federated X. Does anyone know what Federated is? Okay, the usual suspects. So it's a storage engine that allows you to connect to remote MySQL servers through, you have like a local kind of a view, but it's actually a connection to a remote server and stuff. And Federated has been in MySQL for quite a while, and it's a fairly broken feature. It's there, but it doesn't work well. And Federated X is kind of a improved version of Federated. So it's a community-driven, open source, and improved. Then there's a storage engine called Aria. I guess that's how you pronounce it. Does anyone know what Aria is? Does anyone know what MyISAM is? 3 nods. So MyISAM is kind of the traditional engine for MySQL, no transactions, nothing. So basically you store data in a very simple format, and then you have indexes in a different file to access the data. The problem with MyISAM is that there's no crash recovery, no safety. If your server crashes during a write, your table will be in a state of, well, in between a write. So you will have some rows updated, some rows not, and you have to do some kind of recovery process to be able to use those tables again. So Aria is kind of the same thing, except that it has crash recovery. So it's kind of crash safe.
So it does transaction?
It does not do transaction, it's just crash safe.
Oh.
One state, but it's crash safe per statement. So one statement will be, if it's crashed during the statement, it will be rolled back. But so it's not transactional, but it's statement safe, kind of.
Does it still have the kind of locking conflict issues that MyISAM had?
Yes, it's table level locking. So it's the same. It's not much better, it's just crash safe. There are plans to expand this to make it more transactional in the future, but it's not done, and it might never happen. But still, it does improve a bit from having an engine that's not crash safe. It's crash safe. All right. And by the way, many of these features are added by the Monty program team. Some are added by others and stuff. So I'm not saying that all of these features were added by Monty program, but all of these features are present in MariaDB. So someone created them and then they were added. Another feature added in MariaDB 5.1 was microsecond support. So MySQL until now does not support any granularity below seconds in for example, process list or the slow query log and stuff like that. And this was added in 5.1 in MariaDB. So here I do a process list. Well, actually, it's an information schema.process list command, and I see the execution time of a query with millisecond precision instead of seeing it with second precision. Because, of course, a second position on a database is not very precise. So that's a fairly good add-on. So you get it in the process list, in the slow query log, and in other things. Another addition in 5.1 was a thread pool. It has a star here because there's actually a funny story related to this. So the MariaDB team added a thread pool in 5.1. I mean, the idea of a thread pool is to, by default in MySQL, every connection is a thread, which works to a certain extent. The problem is if you have a lot of connections and they're really small, they do really small operations, it means that you will have a lot of context switches on the CPU level, right? Because you have to switch between the different threads. And you don't have as many cores as you have thread. If you have 1,000 threads, you're not going to have 1,000 cores. And that creates some weights on the CPU level. So instead of having the CPU do the context switching, you can pool your connections into a specific set of threads so that the CPU doesn't have to do the context switching, but normally you would have as many threads as you have CPU cores pretty much. But it only works if you have this specific scenario where you have small transactions, small operations, and a lot of connections. Well, anyway, so this was added in 5.1 to MariaDB. Then later on, when MySQL, so Oracle came out with MySQL 5.5, they added a thread pool as a closed source plugin. So if you get the enterprise edition of MySQL, you have to pay for it. Then you also get this closed source thread pool as a plugin that you can use. This is all fine, except for one problem. This closed source thread pool actually worked better than the one in MariaDB. And this infuriated the MariaDB developers. So they actually had to recreate the thread pool. And in MariaDB 5.5, there's a new version that is equal to the one in the enterprise version of MySQL. So that's why there's a star there, because they added it in 5.1 and then they had to re-engineer it because they were outperformed by Oracle.
Competition is good.
It is, it is. I mean, this whole project, I mean, or product is a good example of I don't know, how the MySQL ecosystem is actually thriving since the acquisition of Oracle. Now there's much more competition out there on different products and stuff. Right, then the MariaDB, the multi-program team also had a lot of optimizer features. This, well, had to do a lot with the fact that the whole optimizer team actually joined Monty in Monty program. So there was an optimizer team of around 4 guys, and 3 of them joined Monty as soon as he created a company, and then the 4th guy eventually joined as well. I mean, there are now others working the optimizer team at Oracle, but of the original team, they all joined Monty, so it was easy to add optimizer features because they were all there. So one of the optimizer features here is called table elimination. It's a feature that's useful in only specific cases, and well, that specific case is if you have this type of anchor schema. So an anchor schema is a database that's extremely normalized. So instead of storing, like, it's almost like going beyond row-based to column-based, except that you are in a row-based database. So you don't store all your attributes for an entity in a table, but you have a table for each attribute, right? So this makes the, for example, here we have an actor is the entity. Instead of having a table with each actor, a column for name, a column for rating, a column for birth date, you have a specific table for each of these attributes. The reason for doing this is to be able to have more flexibility in adding and removing attributes. And you might have some entities that have certain attributes and other entities that don't have these attributes. So you get a lot of flexibility. But of course, it's a nightmare to maintain. Well, not to maintain, but it's a nightmare to query because you have to do joins of 400 tables or whatever you have. So normally what you would have is you would have a view that makes this into one table, and then you query that view. Right. The problem is that the MySQL optimizer, when you query this view, it will join all these tables every single time when you query this view, because that's how the optimizer does it. Even though you're only looking for certain attributes, it will still make the join algorithm with all the tables. And that's where table elimination comes in the picture. It will actually remove the tables that you're not using in this join. It will remove them from the join process. So it's something that's useful mainly if you have, well, actually this is something that you could have if you use some kind of machine-generated query. So if you don't actually write your queries, you have some kind of middle layer that writes queries for you. because the middle layers always have to be flexible, they might actually have an anchor schema behind the scenes and do queries like this. In this case, this will help you a lot. So basically, it will notice that this birth date table is not used in this query. We want to look at the rating, and we're looking for a specific actor for the name. So we don't actually use the birth date table. So it's eliminated from the query process. And that's basically done by the optimizer. If you use standard MySQL, it will include all the tables on this mode.
That only works if it's a one-to-one relationship, right?
Yeah, I mean, it's specific for this anchor schema, whatever you call it, schema, anchor schema.
So it's include the tables at the end of filtering, right? Because it is in the select statement, the birth date is in the select.
Yeah, so this is the column that exists in the actor table, but not in the birth date table.
Okay.
It only works for left joins.
Yeah, I mean,
If we did an inner join, it would actually be using the table.
yeah. I mean, it basically only works if you create this view. I mean, it's basically, the use case is when you have a view and you access it through the view, because the view will be a set of left joins, because otherwise the view wouldn't work. All right.
So is it going to be, and I'm sorry, this might be a kind of a dumb question. If you go to the trouble of creating the view first, if you have a lot of individual queries that you could otherwise be doing those same joins on, or you're getting more efficiency out of the view than you would just doing that join with the query?
No, you would get more efficiency out of doing the joins yourself. But so normally, I mean, often this is created by a middle layer. You don't actually write the queries. It's the middle layer that writes them for you.
Okay.
And so this, you would, if you, instead of you just switch to Maria, you would just suddenly all your queries would be faster, and you don't even write the queries yourself. I mean, it's rare to use an anchor schema that's created by hand, because that means that you actually have to write all these queries yourself. You have to figure out, you know. So it's mostly created by some kind of middle layer. Right.
Matt?
Yeah.
Is there a particular use case that, because this feels like maybe ORMs, I mean, were there particular customers coming to?
Yeah, there were particular customers who had this problem.
Are they like specific ORMs you can mention that people?
No.
It feels like a use case where lots of people run ORMs. Are there particular ORMs that have this model?
No, I actually don't know. I can't remember. I've heard it, but I can't remember, so I can't tell you.
I think I have seen similar schemas on content name systems
Okay.
to give the flexibility to add new fields.
Yeah. Yeah. So I mean, yeah, I don't remember. I can't give you the answer to that.
One more. From a system administrator's perspective, I'm a lot more likely to be monitoring a running application using tools like Inotop than I am to be actually hacking code myself.
Mm-hmm.
If say somebody had created exactly this view that you've got on the board here and were running queries in their application against that view as you're showing in that last query down at the bottom, if I was monitoring in Inotop, would I see the query at the bottom, or would I be seeing the raw query with the joins?
No, you would see this at the bottom.
Okay.
So you wouldn't see the view.
Okay, which basically tells me no, my developers are not using views.
Yeah.
Well, you don't know.
I mean, you don't know if it's a view or a table. It looks like a table, but it's actually a view.
Well, no, I do, because I know what all the table names are.
Well, yeah.
I never see something popping up that's not a table.
Right, but how do you know what the table names are?
Because that's an application that I manage, and I'm at
Okay, so you know that
console frequently.
if you look at the information scheme where you like show tables, it will still show the names. But you know to value of development.
Yeah, I don't typically develop the code. I more tend to get involved when they code themselves into a corner and don't know how to get out of it. I'm more of a troubleshooter than a coder myself. I can frequently draw a big red circle around, this is where you screwed up, and then come and fix it.
Well, so if you guys are having slow queries and it's because of this, install MariaDB and it will go away.
Fair enough.
That's the remedy. All right, there's other features. So pluggable authentication was added in MariaDB 5.2, so you can actually, you can use plugins to authenticate users. And they created a PAM plugin as well. A pretty cool feature is user statistics. So in MySQL, you have lots of statistics, but it's all on server level. You can get it on a session level, but it's on the same session you're in. and that's basically it. You can get server statistics or session statistics, and that's all you have. So this patch was originally created by either Google or Facebook. In any way, Mark Callahan's team. I don't know if it was before he moved or after he moved, but one of the other. And it was then refined and so forth, but it's now in Maria. So basically it gives you information schema tables where you get information on per client, so per host, how many connections you get from this client, how much data access and stuff like that, how many rows, how many bytes sent and stuff like very specific statistics on each client, on his user account, and then statistics per index and per table as well. So very useful for monitoring how much, what client is using what, how much usage for each client, and what tables are being used, which indexes are being used, and which use cases, and so forth. So this is stuff you don't have in MySQL at the moment.
So the client statistics would be like, say for example, you've got a DB server and you've got 3 application servers running Apache. The client statistics will tell you which of your app servers specifically, like what it's doing, or?
So it's the primary key for the client is the host name, if I remember correctly. The primary key for user is the user account in MySQL, and if I remember correctly, the client, it's the host name. So it's per host name.
Okay.
So with index statistics, can I tell if I have indexed or they're never being?
Yes. So this index statistics table will tell you how many times each index has been used. So also if your index is never used, you will have a 0 there. So it's very useful as well. Of course, you shouldn't start the server and look at this and remove indexes, but after a few days. Right, so these are fairly useful stuff. Other things in MariaDB 5.2, virtual columns. So it's kind of similar to, well, I don't know. It's basically creating a column as a function of, well, other columns or other things. So you have a kind of a functional column. You have a column in the table, and the value of this column is based on some kind of functions and the other columns in the table. And they can be either virtual or persistent, with the difference being, of course, persistence is actually stored and the virtual is calculated on the run. And that's a fairly simple feature to add, but it's been asked for quite a few years.
Persistent columns updated when the values?
Yes. Yeah, you don't have to worry about updating it. It's updated automatically.
Is it materialized?
So the persistent, they're persistent, and the virtual are calculated when you access the columns.
So rather than writing calculations into your application, you can just build that directly into the table?
Yeah. And the cool, I mean, yeah, okay. I was going to say something, but I'm not 100% sure, so I'm not going to say it. Yeah.
So is that something you might use, like, just for a really simple example, is that something that you might use, like, you knew you're going to be constantly summing fields in a row, you might create a column that would just have that sum?
If you're summing fields in a row, then yes, for example. So this can be used for, I mean, you know, a lot of things. If you, for some reason, want to store your, I don't know, host names in reverse order, you can now store them in both. You have them in the real format and in reverse as a function, so you don't have to. I mean, it removes some logic from the application layer and put it in the database. So it can or cannot be useful depending on your use case, right? I mean, pretty much all of this, you could also do it on the fly in your application layer.
Sure, but then I have to debug what my developer did wrong when they implemented.
Well, exactly. So, I mean, it's a cool feature, but you don't have to use it, right? It's there. Use it if you want. Another thing is the Sphinx storage engine. Who knows what Sphinx is? 3 people, okay. Sphinx is a kind of a full text search. So MySQL has full text search, but it's only available for MyISAM, and it sucks. I mean, frankly, it's not very good, right?
Well, even MySQL 5.5 and 5.6, it doesn't be that.
5.6, right?
Yeah, 5.6.
Yeah. Well, so it's not there yet. But anyway.
You sure about 5.5?
5.6.
5.6.
Yeah, 5.6.
Yeah. So anyway, but this was in December 2010, so we're talking 2 years ago, and 5.6 is not out yet. Anyway, so Sphinx, well, the implementation of full text indexes in MyISAM has sucked pretty much since it was there. It was used in the beginning, but quite a lot of people who had heavy use for full text searches realized that it wasn't good enough, and they used something else. And Sphinx, so Sphinx is a full text indexing utility. So you have it, you use MySQL and you use Sphinx, and then your full text searches in Sphinx, and then you get back your results. I mean, a bit like a key value store, except that it's a full text indexing store. You get your results back, and then you get the actual row from MySQL, right? So you need two steps. You go to Sphinx, get the results, and then you go to MySQL to get the row. What they added in MariaDB was access to Sphinx through the MySQL layer. So you don't have to do two steps. You don't have to first access Sphinx through a native Sphinx call and then go to MySQL, but you can access both through the MySQL calls, and that's basically the idea. So Sphinx looks like a storage engine, and you access it with SQL. It's a slightly modified version of SQL to access the Sphinx engine, but you get results, a query result set, and furthermore, you can actually do joins between the Sphinx storage engine and the MySQL. So you can do one query and use Sphinx as a full text engine and get the results in the same query.
But the backend is still actually a separate daemon?
Yes, the backend is still actually Sphinx. So you still have to install both and use both. It's just that you have easier access to it. One point of access instead of two.
You don't have to build connections to Sphinx in your application. You can just reuse your existing MySQL connection from your app.
Yes. All right, another thing added was the segmented MySM key cache. Pretty much no one uses MySM here, so I'm not going to go through it, but the idea is MySM has a key cache, and well, there's one key cache, which means that it's kind of has a mutex, which on multi-core systems becomes easily a bottleneck. So now you can segment it into up to 64 segments to be able to use multiple cores better. Here's a nice graph. The guys at Maria did some pretty serious benchmarks with lots of different options. I just show one of them, but this is kind of the order of magnitude you can gain on a system with multiple cores and lots of threads. But of course, only if you use MySM. InnoDB had similar problems, and they did similar things to their InnoDB buffer pool as well. But that's included in 5.5. So both MySQL and MariaDB 5.5. Right. Then there was MariaDB 5.3, where they added quite a few other features. So first of all, some that you could call no SQL features. So the first one is handler socket, and this was created by a Japanese company or a Japanese guy who used to be a MySQL consultant. Basically what handler socket does is that it allows you to directly access the InnoDB engine, so bypassing the SQL layer in MySQL. Which can be good and can be bad. The idea is that it will be faster to access it. But the problem is that you can, of course, because since you bypass the SQL layer, you can't do complicated stuff. You can do simple stuff. So crude operations, create, replace, update, and delete. So simple operations, and you talk directly to the API. So again, this is very useful if you're running a lot of simple operations, so kind of a batch of inserts or lots of operations on one table. Then this will be much faster than passing through the SQL layer.
It's basically just operating as a document store at that point?
Well, no, it still has the storage. The storage is the same. It's just a different access method. You don't have to use SQL. So it's kind of, it's still not a NoSQL. It's still a database, fully ACID and all that stuff. It's just that you access it through a simplified API. So just the access method that's different, which removes some of the layers like, key cache invalidation or whatever you would have there in MySQL. So it makes it faster, but I mean, it's marginally faster. So it's not like, oh, you should, instead of using SQL, you should write everything in this. No, it's specific types of operations where it might make sense, like small operations and large batches of these small operations in one go. Another cool feature in MariaDB 5.3 is dynamic columns. Basically what dynamic columns is kind of like now we're coming close to like a document store. It allows you to store attributes in a column where basically for each row you decide which attributes apply to this row. So it's kind of, I guess, like an array or something, but you define yourself how many attributes will this row have. So basically you create a blob. Okay, I'll show an example. You create a blob. Here's a table. We have a blob. And then we use functions to access stuff inside the blob. And these functions allow us to define attributes and give them values. So for example, the attributes have numbers. So well, at the moment we only see 3 different attributes, but you could have any amount of attributes. And then each row can have any number of these attributes, right? So for example, here we have some kind of store, web store, and basically each row corresponds to a product. But because we sell pretty much everything, not all attributes will apply to all products. So for example, we have one attribute that corresponds to color. The attribute number 1 is the color of the product. Well, pretty much all of our products will have a color, so every row we insert will have some value for attribute 1. However, the second attribute, attribute number 10 is size, and well, only the clothes will have a size. Then we have one attribute which is the operating system, and well, the t-shirts won't have an operating system, so they will have no entry for this attribute, and so forth. So it allows you to have a huge amount of different attributes per row without creating a table with a huge amount of columns. So it's close to a document store, I guess. And you can then access these values through these functions, column list, and there are other functions for accessing stuff, accessing this row, get column and stuff. Right, so here we've created this table, we've inserted these rows, and now we can do searches. For example, okay, give me all the products where the color is black, and we find all the products with color black, because attribute 1 was color. And well, okay, the other example is just give me all the different colors in the table. But so you can do any type of search. You just have to define, okay, which attribute am I looking for, and what do I want this attribute to be.
Can you use hashes for your attributes, or integer indexes only?
It's integers only. But what you store, I mean, here we store strings, but in theory you could store anything, but because it's a blob, the backend is a blob, so you could in theory store anything. But here we're storing strings. Well, actually the size was well, we didn't have, it was a string as well, actually.
I was just thinking it would be really nice if instead of, attribute 10, you can have attribute size, and you can actually see what that data is supposed to be.
Well, so if you want to do that, then you create a lookup table, and you're close to actually having a database, real database.
Yeah.
So I mean,
When you retrieve operating system for a shirt, where you get null back?
if you
If I look for operating system for a shirt, do I get null returns, or?
You get null or empty string, I can't remember. Can you remember, Daniel? No, it's null or empty string, I'm not sure.
Is this indexable?
No, at least not at the moment. So you can't index you mean the attributes inside the column? No, you can't index them.
I hate to ask the question, but why would I want to do that instead of creating a real honest-to-goodness related table?
Which one? I mean, you mean the whole creating this at all?
The whole dynamic column function.
So if you create a table for this, the problem is if you have a wide diversity of products, and you have the attributes depend on the product, you have to either create different table per product, right? So you would put all your phones in one table, or your t-shirts in one table, or you create a table with lots of columns where most are not used, which is not very optimal. Or you use an anchor schema kind of style where you have it highly normalized. Those are kind of the 3 options you have. Most web companies would use a document store for this instead of they wouldn't even look at this because it's easier to use a document store. But this is kind of the SQL version of a document store, kind of. It gives you the flexibility of a document store while still having SQL, and then being able to combine it with actual relational stuff. So that's a neat feature. I don't know how used it is so far, but yeah, it's a feature. Yeah.
If like query on was the one, wouldn't that you will very inefficient? Because
Sorry?
It's not going to be efficient, right? You cannot index on it, you have to evaluate it.
No, I mean, it's like a document. So the question is whether this is efficient, and the answer is no. It's like a document store. You don't index what's in the document store either inside the value column. Yeah, it's no SQL-like, right? It's not, if you want it to be indexable and really fast, then you do the anchor schema, and then you can do it.
Can you nest these things?
Can you nest these things? Oh, you mean like an attribute? No, not at the moment. No, I don't think so. I don't think so, but I haven't tried it, so I don't know. So my answer is I don't think so. Feel free to try it and let me know what the results are. All right. Where am I? 12. Right, so still on my 5.3, some other features added. A few replication enhancements. So one actually pretty cool thing is who knows about the binary log in MySQL? Quite a few people. Who knows about the different formats of the binary log? Okay, so the binary log can be, the content of the binary log can be stored in two formats, right? You can store statements or row images. So the binary log, by the way, for those who don't know what it is, it's kind of a redo log it's a redo log of all statements that change stuff on the server, right? So if I do an update, the changes of this update will be stored in the log, so I can later use it. It's used for replication, but it could also be used for incremental backups and stuff like that. So in MySQL, I can choose whether to store the statements. So if I make an update, I store the update in text format. Well, it's actually in binary format, but it reverts to a text format. So I store the actual update statement. And this is good and all, except for the fact that there are quite a few statements that are non-deterministic, right? So you have a statement, you use functions. The result of the function depends on conditions on the server. So if I rerun the query later, it will actually produce a different result. And because the idea with the binary log is to be able to use it for replication and or backups, I want the results to be the same every time I run the query. So in MySQL, traditionally we only had statements, so we used a lot of weird fixes to do this. We had like set timestamp before, so we fooled the server to think that it was actually this time. We execute the query, we go back to the normal time, and stuff like that. But it's impossible to catch every single non-deterministic function, and you can have your own functions and stuff like that. So instead of worrying about this, the row-based format was introduced. So instead of storing the update statement, for every single row, we store the image of the row before the change and the image of the row after the change. So we don't worry about which statement actually caused this change. All we care about is this is how the row looked, this is how it now should look. So it's completely deterministic. We don't care about the function. All right. So this was introduced in MySQL 5.1. And it, well, of course, had a few bugs initially, but eventually it was fairly stable. But then we started getting complaints from customers like, all right, so I had a guy who did a delete, and now I want to restore from backups and not do this delete. And I'm looking at this row-based binary log, and well, it's all row images. I can't find the delete. So that was kind of a problem because you didn't get the statement anymore. And again, it's a very simple thing. It was asked by customers. So basically what MariaDB did was that they introduced, they also store a statement, but in a commented fashion, so it will not be used. However, you can actually now search for this statement inside the binary log. Nice. So that's a simple but useful feature. And some other features about replication, some extensions to OpenGIS, and so forth. Another really, really cool feature, again, does anyone know, alter tables, right? In MySQL, if you do an alter table, first of all, the first thing to know is that the performance of an alter table in MySQL is as slow as it can be, right? So the first thing MySQL does when you do an alter table is, all right, let's lock everything, let's create a new table, and let's copy everything from the old to the new table. independently of what your alter table actually does. Even if it just says, all right, I want to change the name of a column, we still do a copy of everything, right? You have a table with 10 gigs of data, it's going to take a while to copy the table, right? And your table will be locked during this operation. So alter tables in MySQL are slow. But problem number 2 is when you do an alter table in MySQL, you know that's slow, but you don't know how slow it is, right? So you want to do an alter table, you do it, and after 10 minutes you're like there, it's not done yet. However, if my statement will only take 11 minutes and I'm already done 10, I shouldn't cancel it now, right? So you wait, you say, okay, wait. Then it's 30 minutes, and I'm like, all right, 30 minutes, I have to cancel it now. But what if it's 33 and I'm so close and I cancel it? So you're stuck with a dilemma, when should you cancel and stuff like that? Well, in MariaDB 5.3, we actually introduced, or they introduced, a progress report for alter table. So you will actually know how much of the alter table is actually done. So you get it, first of all, on the command line. So if you do it in the client, you actually get on the command line, you get the percentage of the operation, and you also get it in the process list. So if you look at a process list, you will actually see the progress for an alter table statement. So now you wait your 10 minutes, and you look at your process list. All right, I've only done 5%, so you can extrapolate, okay, it's going to be 20 times 10 minutes, this statement. So now you know, okay, should you cancel the statement or wait for it to complete? So that's a pretty cool feature. I mean, DBAs ask for this feature
a lot. Cancel it, is it immediate, or does it need to roll back again like 20 minutes?
It's pretty much immediate, because so what it does, the alter table, so it first of all, it locks everything, so no one can write to the table while you're doing this. So everything, your data is still there, and then it creates a copy of the table. I mean, it creates a new table with the new format, and then it starts copying data from the old to the new table. So the old table is constantly there, and it never changes the old table.
Okay,
so
MySQL is doing it that way, but Maria is doing different. Like,
no, it's the same.
Oh, again, it's copying. Even
Alter table is as bad at Maria as in MySQL.
Okay, so even for column name change, again, you are copying it.
Yes, as bad. It's just that you get a progress report. That's the only difference. Yeah.
So in MySQL 5.6, alter table become all online. So the add drop column, bring that all online. So it's all accessible.
Is that a question? Or it's not a question, so I can't repeat it. It's a statement. All right, thank you for that. And then they introduced quite a few optimizer enhancements in MySQL 5.3. I don't have time to actually talk about all of these, but I'll just mention. So number 1 is subquery optimization. So subqueries were introduced in MySQL 4.1, and it was a feature everyone was saying, MySQL is not a real database, they don't have subqueries, right? So something that MySQL had to introduce. So we put subqueries there, good, checkbox, subqueries, done, we have them. People, oh great, you have subqueries, should be used. And we were, God no, the performance is abysmal. And it was abysmal. So the subqueries in MySQL, well, up to MariaDB 5.3, performed really badly. And well, everyone knew that because we were honest, we told people, I mean, please don't use subqueries, they're there, but please don't use them. However, of course, some people still use them and would complain about the performance. And also, if you use middle layers, they might actually have subqueries there, and they would just be bad. So MariaDB introduced a lot of subquery optimizations. Number 1 is, well, just to go through this briefly, number 1 is that if a subquery can be rewritten to a join, it will actually be rewritten to a join by the optimizer and performed like a join. That was the number 1 thing we used to say to customers back in the day. Don't ever use subqueries, use joins if you can. Right. Now you don't have to worry about it because the optimizer will do it for you. Another thing is if you have non-correlated inquiries, it will actually materialize the results instead of re-executing the result each time. And there's also a subquery cache. So the subquery actually has a cache instead of having to re-execute it each time. You have a cache where you can access it. All right. I'm running out of time, so. They added some join algorithms as well. Traditional MySQL only has nested loop joins, and MariaDB has added a few more, and yeah, all right, I'm not going to go through this. Some other optimizations for derived tables. This is also subqueries. So if you have a table like in the from clause, there's optimizations for making this faster. So basically, if the table in the from clause is mergeable, so basically with the main query, it's actually merged into one query, processed like one query instead of first executing the derived table and then the other. And a second optimization is that you can actually have an index. So if you cannot merge the two tables, you have to first create a temporary table with the results of the first query. The optimizer can choose to create an index on this temporary table and then use this index when the results are merged. So another thing. And then there's a few disk access optimizations. Index condition push down. So basically, if you have a where clause, you can that's not on an index, you can actually push it down to the to your index access algorithm. So instead of retrieving all the rows first with the index and then filtering them on the additional where clause, you can actually filter them already when you're looking through the index, which for queries where you get a huge result set from the index lookup, this is useful. And some others, and I don't have time. Another big feature is group commit. And this is perhaps the #1 kind of performance feature for MariaDB. So group commit basically, this is InnoDB here. So just to tell you the background for group commit. So basically InnoDB has stuff stored on disk, right? There's a buffer, things are in memory, and of course when you do transactions you work on the memory part, right? The problem is that when you commit, this has to be durable. So if you have a server crash, the changes have to be durable. So flushing your buffers to disk will take a lot of time because you have lots of data blocks and stuff. So instead of doing that, what you do is you have a redo log. So you keep your transaction, you keep a log of your transaction changes, and instead of flushing the actual changes to disk, you just flush your redo log to disk. So every time you commit a transaction in InnoDB, it has to flush the log to disk to make sure that if there's a crash, even though the data on disk does not contain these changes, we can actually reproduce these changes by going through the redo log. And that's how InnoDB achieves durability, said in very few sentences. All right. But then there's a second thing, the famous binary log, right? Because the binary log contains all the changes that we do to the data. We have to make sure that what's in the binary log is synced with what's on the disk, right? So if we do a commit, it's not enough to flush the redo log to disk. We also have to flush the binary log to disk, right? Because in order for this binary log to be useful, if we have a crash and we recover, they have to match. The binary log has to match what's in the data. Otherwise, of course, it's not useful anymore. So we have to make sure that these are synchronized. And this basically causes, it's a long story of how it's actually done. You have to prepare and make sure, you have to make sure that you don't sync one and not the other, because then they're not in sync, right? So basically it boils down to approximately 3 fsyncs per transaction, right? This means that if you have a system that's IO based, I mean IO is your performance limit.
IO bound.
IO bound, thank you. I'm losing my words here. So if you have an IO bound system, you want to do some, this is the problem, right? Because you have to do, for each transaction, you have to do 3 fsyncs. So, and the group commit feature, what it does is that it groups multiple transaction commits that are waiting to be synced. It groups them together as one operation. And that's basically what it does in all its beauty. And there's been many implementations of group commit. Facebook did a few. MariaDB did one. The Facebook version did not perform as well. Here's actually Facebook's benchmark. So they made their own patch. This is MySQL with no group commit, right? So normally it's not a problem until you start having lots of concurrent transactions, right? So here's the number of threads is the x-axis, and the commits per second is the y-axis. So Facebook made a patch. The performance was far below the MariaDB patch. The Facebook made another patch, which is not on this graph. it was somewhere here, so still far below MariaDB. And that's after that Facebook stopped making their own patches and said, okay, we'll use MariaDB. So Facebook actually, they don't use MariaDB, but they use the group commit feature from MariaDB, right? And well, actually the MySQL team is now also working on their own implementation of a group commit feature, but it's just been released in our labs version, so I haven't seen any benchmarks comparing these. But this has been GA for a while already, so it's out there. MariaDB 5.3 and MariaDB 5.5 has this feature. So if you're I/O bound, well, this can improve your system quite a bit if you look at the difference here. You go from...
That's only going to really make a difference if you're right I/O bound, correct?
Yes, of course, but normally if you're I/O bound, you're right I/O bound. Because the reads, you don't have to actually, you can actually use the buffers, right? You don't need to read from disk. Well, depending on your size, yeah, okay. Depending on the size and all that stuff, yeah. But, I mean, let's say many of our web customers make sure that their RAM is as big as what they have on disk. I mean, of course, that doesn't apply to all customers and, you know, data warehouses and stuff, it's impossible, but we have a lot of web customers that prefer sharding their data so that on every machine it will fit in memory, what they have. But you still have to write, of course, all your writes to disk. All right. So MariaDB 5.5 includes everything we've seen so far, plus a few other features, but nothing really major. The one major feature is the rewrite of the thread pool, right? Because the closed source version from Oracle was better than the one in Maria, they had to rewrite it. And some other features, this takes too long. Limit rows examined and stuff like that. So then next MariaDB, what's the next thing? This is kind of a wish list. MariaDB 5.5 was released in April, so it's fairly new. This is kind of the idea of which features will go in, but it's not by far done yet. And there's also some speculation on how the versioning will go and so forth, because MariaDB would like to release fairly often, but MariaDB is kind of bound by Oracle releasing MySQL and stuff, so there's a possibility that MariaDB will now diverge a bit in version numbering from Oracle. And also, many of these features we saw here that exist in MariaDB are now being implemented by Oracle into the standard MySQL, but not in the same way, right? So they will do the same feature, but a bit differently. And if the MariaDB feature is better, what do you do, right? So do you take the worst feature from Oracle to be compatible, or do you take the better feature and say we're no longer compatible? And that's kind of the dilemma MariaDB is at now. Should it stay a branch, or should it become a true fork with no remerging? So one of the possibilities is that it will use specific features from the coming versions of Oracle MySQL, but not all of them, because some of them will be the same that have already been implemented by MariaDB. And where can you get MariaDB? You can get it on these systems, and MariaDB also has its own YAM and apt repos, so you can go to MariaDB, you can put these repos in your systems and download them. And right, we have 5 seconds for questions.
We have a BOF tonight at 7:30.
And we have a BOF tonight at 7:30. Where? HP is the room, all right. If anyone has any questions, I have not a lot of time, but go ahead. Yeah?
I saw that I saw some stuff in Ubuntu's blueprint on making MariaDB available in the default repos as a MySQL alternative. Do you have any news on that?
That's basically the last I heard as well. So the question was about Ubuntu, whether MariaDB will be there as an option. And the latest I've heard is that that's what they're aiming to do, have an option. You could choose between the Oracle version and MariaDB.
It's not going to be a replacement, it would be
an alternative. Any other questions?
Right now, if you install from the PPA on Ubuntu, you'll unfortunately break a lot of packages because it's not actually labeled as a MySQL alternative. So the package manager doesn't really understand that you have and are using MariaDB. If you're installing a package with a MySQL dependency right now, it would tend to break because it doesn't know that you're using MariaDB, and so you already have your MySQL. It will attempt to say, well, I need MySQL, I'll pull in MySQL, and the port's already used in cats and dogs and fighting.
But that should be fixed.
But it's on Ubuntu's blueprint to fix that and have MariaDB officially as a MySQL alternative that will satisfy the MySQL dependencies when you install a package. Which
yeah. But it's already available in these systems now. It works already now in this system, right? All right. I guess I have to end. So thank you, and you can.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HDIP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems, and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you will you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.